All right, this is Ubaid on behalf of V Electronics, and in this video, we'll be talking about our sample mean as well as our central limit theorem. Okay, now in the last video, we talked about taking a sample from a population. All right, and when you take that sample, if the sample is large enough, if you figure out either the sum of the sample or the average of each sample, which is represented by this symbol over here. Okay, that average and the sum will show a normal distribution, will show a bell-shaped curve. All right. Now, when it comes to your sampling distribution of the mean, okay, if you draw random samples of size n, let's say your size n, this is 50 more than 30. So if you draw random samples of a certain size, okay, the sampling distribution, okay, or the distribution of these values, okay, the distribution of the mean, okay, is also called sampling distribution. Okay, so the key word over here is sampling distribution. This is sampling distribution. And sampling distribution basically says if you draw random samples of size n, okay, if you draw random samples of size n, okay, the distribution of mean, the distribution of the values relevant to mean, or average, okay, is the sampling distribution or sampling distribution of the mean, which is this word over here. All right, and this sampling distribution follows a bell-shaped curve or normal distribution. Okay, so if you were to take this concept and use a formula to express this concept, to show this concept, okay, this formula will be, okay, your x, excuse me. So let's say this will be your x random variable. Okay, this is your random variable with the sample mean. This is approximately, okay, your average, your standard deviation, so the average of the population, your standard deviation over root of your sample size, which is n. So this is the formula for sampling distribution, and this is the formula that you will use when figuring out your sample mean. Okay, so ux is also equal to your sample mean. All right, so this is your population mean, which is also equal to your sample mean. And your standard deviation, okay, for the population, this will turn into your standard deviation of the population divided by root n, and this will be your standard error of the mean, or okay, the standard deviation for your sample. Okay, this is your standard deviation for the sample.